To some degree, you probably take for granted that your phone, laptop, or electric vehicle doesn't overheat and shut down during heavy use. That's because technology like thermal conductive pads has been quietly performing a stellar job of keeping modern electronics going. In this video, we'll break down what thermal conductive pads are, how they work, and the materials they're made from. Thermoconductive pads are heat-managing components used in electronic devices to draw heat away from critical sources, such as batteries, and spread it across a product surface area. Their primary purpose is to assist components like heat sinks in maintaining safe operating temperatures, preventing system overloads or failures. These pads are soft and conformable, allowing them to fill air gaps between uneven surfaces, which enhances their thermal performance. The materials used in thermoconductive pads can widely vary based on the application, but typically include thermal tapes, silicone foams, graphite sheets, and ceramic fillers. The specific choice of material depends on what surfaces the pad will bond to, required thermal conductivity, and the application's design complexity. Because of their specialized nature, these materials are more expensive than standard flexible materials, and usually come in smaller rolls, increasing both material cost and setup time for production. When designing thermoconductive pads for manufacturing, several factors need to be considered. Material selection is crucial. Not only does it impact performance, but it also determines how easily the material will be converted. Roll-based materials with supportive backings are easier to die cut and handle during production. The thickness of the pad also plays a significant role. Thin pads are suited for compact electronics, while thicker ones might be needed for gap filling in larger applications. Quantity is another consideration. These pads are often produced in small batches due to high material costs in niche applications. Lastly, the pad's application process can affect the design. Simpler shapes with adhesive backing are easier to apply, while complex shapes or pads requiring heat activation or solder can add to manufacturing time and cost. Alternatives to thermoconductive pads include thermal paste and glues, which are useful when complete contact with no air gaps is essential. These alternatives may offer longer-term stability and higher thermal performance in specific scenarios. However, they can be messier and more difficult to apply consistently compared with pre-cut thermal pads, which are easier to handle and better suited for applications where the interface material also needs to act as a structural element. To find the right thermoconductive pad, the best approach depends on the complexity of your design and the volume needed. Off-the-shelf pads might work for simple, low-volume application, but for custom shapes, specialized materials, or larger orders, it's often necessary to work with a flexible material converter. Converters can help you refine your design, source appropriate materials, and produce prototypes, ensuring your thermal pads perform effectively and are manufacturable at scale. If you want to find more about how a converter can help your production, feel free to visit our Learning Center for more videos and articles, or reach out to us directly. Thanks for watching.